Swayam Prabha. Digital India. Educated India.
So, hello student. So, today we are the last lecture of module 8 chemical transformation. So, until now I had discussed about the special incineration process, the types, and there are two major issues on incineration process. One was fly ash production and solid residue production, okay, and also the treatment also I had discussed. Now, I thought of, rather than finishing this module, I thought of why not to give some case studies, because in India you know, in the Swachh Bharat mission there are number of cities are coming with the waste to energy plants, especially the incineration plants is getting installed. So, I thought of some few case studies onto that, and also there one more chemical transformation that is now specially for the solid waste, but also could be possible for organic waste, maybe agriculture waste, special segregated waste, even the plastic. Suppose if you are able to get segregated, it's possible to go for such kind of chemical transformation process that normally called as a pyrolysis and gasification process, which we are going to discuss today. So, we are at the fifth function element, transformation, okay. And now this lecture is a waste to energy plants, some case studies and pyrolysis and gasification processes. So, here is the first question I started with this: why India's first waste incineration plant has failed? So, in 1987 the first incineration plant come up in Delhi, that is a Timarpur disposal site. That was the capital cost of 20 crores. You can understand in 1987 the cost was very high, and that majorly that technology has come up from the Denmark. Plant had designed to use around 300 tons of MSW per day, and also the idea was that from that we will able to produce 3.75 megawatt electricity. That was the idea. It was not only to reduce the waste or reduce the volume of waste by combustion process, but also was idea was to get some kind of energy out of that, that is in the form of electricity. So, the plant was shut down after 21-day trial operation due to poor quality of incoming waste. So, now you understand that in 1987 only that first rule has come up, waste management rule. There were no proper segregation, even corporation also just they started how best they will be able to collect the waste, and the entire commingled waste as mixed waste they put it into the incineration process. So, after 21-day trial, I think they closed shut down the plant. The calorific value, because of commingled waste or mixed waste, the calorific value of supplied waste was in the range of 600 to 700 kilocalorie per kg, and normally that plant was required to calorific value of 1462.5 kilocalorie per kg, but the calorific value was very low because it was the mixed waste, and you know that in India those period almost 60 to 70% was the kitchen waste or wet waste, and that was putting into the incineration plant. So, there were attempt to supplement the combustion process with diesel fuel, also tried that another fuel could use to produce the energy out of that, but also is failed. And then finally, the expenditure of 1.25 crore of maintenance and insulation of plant that was required to run for the 21 days trial, and finally officially the plant has been shut down in July 1990. After 2-3 years that has been completely shut down. So, I think you got the answer of my question, that why the major issue, see, technology was not the issue, the problem was the waste, the poor quality of waste. See, when you say the commingled waste or mixed waste, there is a highly very poor quality of waste normally for the combustion process. Only the dry waste which is combustible, if we are able to use as an refuse, as an incoming waste, that will be good for the combustion process. Then another plant has come up in Narela plant. This was North Delhi Corporation launches waste to energy plant in 2017. So, this was the one landfill site, the Narela landfill site, and the idea was to use 2000 metric tons of waste per day and generate 24 megawatt of energy. That was the good idea, and also spread over 100 acre of land, and rupees 458 crore has been required to develop PPP model. I will share one special module onto the PPP also, and that the private company was the Ramki, that Hyderabad based company. With their collaboration the plant has been started, and the agreement also was that the electricity generated from the plant will be sold to the local area. There are 2 boilers which was run in the full capacity, consume 600 tons of RDF. So, idea was that in this plant the RDF plant will be there, the dry quantity will get separated, and this dry quantity will only use for the combustion process. That was the idea, not like the previous one, like mixed waste. Okay. So, this was some news, you see. That was the one of the largest solid waste to energy plant, and facility also comprised the engineering landfill. Okay, that was first in Delhi. So, you see here they had another MRF also. So, to get the RDF refuse derived fuel, also the whatever is possible to segregate for the recycling process, like metal which is not combustible, used to get separate out of that, and the waste is further segregated to RDF which is burned above 1000 centigrade to produce electricity, and the fly ash generation was less than 20% of the feed. So, that was one of the very good technology, and the plant alone handle about 20% of Delhi's MSW, I think 2000 tons per day. So, there is another 2 more plants has been come up, Gazipur and Okhla landfill site, and Gazipur also was used around 2000 tons and to produce 12 megawatt of energy, and Okhla plant was the capacity of 1200 tons per day and to produce 16 megawatt energy or electricity. This is the Okhla one, I think that was the another plant in Delhi. So, this plant installed at South Delhi in the capacity of 16 megawatt capacity of 1200 tons of garbage per day. So, that was commissioned in January 2012 and to process about 600 tons per day of capacity. So, the earlier the capacity was 1200, but when it got commissioned the capacity was increased and to produce 16 megawatt of electricity. But I think these are the some news in Delhi, shutdown of Okhla plant. There are a lot of people they were against this incineration plant, and there are, I think, a lot of news has been come up, and the idea was don't burn our health in Okhla waste to energy plant. That was the one, every other local people, they were against of this one, and you know that why people were against about such combustion plants or incineration plant. The major problem was fly ash production, because treatment, already I shared some of the important points to you, that treatment is very important and very difficult also to handle 600, 800 centigrade fly ash gas, and also the solid residue disposal. We are not able to have the proper sanitary landfill for the MSW. It's very easy to get landfill, but I think it's very difficult to handle such kind of waste. This was another waste. We don't want electricity at the cost of our lives. So, a lot of protests, and you know that why. That was, I was sharing that when Delhi seen emitting smoke, which was has been major concern of the residents in the local area. So, in 2016, the NGT, National Green Tribunal, they put up the fine for Delhi Corporation around 25 lakhs because of production of fly ash. So, what was the problem, that the generating capacity of Okhla waste to energy plant has been increased to approved 16 megawatt to 20 megawatt. The idea was 16 megawatt only, but they increased the capacity to 20 megawatt, and the waste handling was approved was 1200 and maximum was 1525 tons per day, but they increased the handling about 2000 tons per day. And only the idea was one single boiler of 750 metric tons per day as commissioned, but there will be 3 boiler has been installed, each of 1500 metric tons per day. That was the problem. And see here where the waste will be calorified, at least 1600 kilocalorie is required, but only they were getting 1300 kilocalorie per kg. So, because of that, proper combustion was not provided for the waste. So, because of that, lot of polluted gases used to be come out from the incineration facility. So, now currently also this plant is not running, and this is one more news. So, the MOEF has been allowed the Okhla plant to increase the power capacity, increase its power from 16 megawatt to 23 megawatt by amending the environment clearance to plant have received in the year 2007 without increasing the MSW intake and without installing any additional equipment, and no further expansion beyond 23 megawatt considered its proximity to residential area. Plant should run in the automatic mode for the stable operation condition, and all other emission parameters should be monitored on the online. So, because of NGT has been come in between and asked the fines of around 25 lakhs rupees. So, okay, now I think you understand that in India still most of the corporation is trying to have the incineration facility, because the managing of 4000, 5000 tons of waste per day is very difficult, and we can't only depend on to the biological treatment facility like composting, biogas production. That could be possible, but for dry waste I think we need such kind of treatment facility where the not only the waste volume should will get reduced, but also if we are able to produce some kind of electricity or power, that is also highly beneficial. And let us see, I think I personally believe that the technology was not the problem and none of the plants, okay. And now also some of the cities are coming with the waste to energy plants like Jabalpur, they are already commissioned, it's running currently. Indore is running one incineration plant. Hyderabad, I think maybe it's got commissioned now. So the many other cities are trying to have the such kind of facility, but technology wise there is no problem. The only problem is that how best we will be able to reduce the emission first, whatever the fly ash emission or polluted air emission, and how best we are able to treat of that. I think we have the our MSW rule 2016. We will discuss onto that. Already gave the proper treatment, what kind of treatment facilities are required. We have special manual is available with that, what kind of treatment facility could be possible. So that is not that those operating people or operating private company, they need to study this particular course to know that treatment facility. For that special manual is also available for their information. But problem is that required lot of fund to operate the treatment facilities. That is why I think maybe the local authorities and even the private parties also is not able to run the that particular treatment facilities. But let us see that in future we will have such kind of incineration plants where we will see that they can run the incineration facility followed by the emission treatment facilities. Now I think I was sharing that there is another combustion facilities apart from incineration, pyrolysis and gasification. Okay. So the first with pyrolysis is also a thermal degradation, but the temperature is only around 300 to 800 degrees centigrade, especially for the organic material in absence of oxidizing agent such as oxygen, steam and CO2. For incineration you need lot of air for combustion process, but this is the without requirement of oxygen, the thermal degradation could be possible. And pyrolysis, unlike incineration, is a endothermic reaction. So I think is a endothermic reaction, means lot of energy is required to run the such kind of plant. So what energy is required? I think more than that energy could be possible to produce. So the same energy you can use to run this particular technology. So this is one small biomass pyrolyzer in Mumbai. So the composition and energy content of the pyrolysis produced is highly dependent onto the waste input and may vary significantly. Okay. See here, I won't say is a problem, but the feed is very important here. Like for the incineration process, I think there also I was talking about we need segregated material. Obviously, whatever is the combustible, that we can put it for the incineration process. But in the combustible matter also, suppose the 5%, 10%, even 30% moisture also, if you feed in the incineration plant, there will not be any issue of that. We can increase the grate length and we can dry first and then we can get combustion. But in this case, for pyrolysis, even for the gasification, your composition of waste is very, very important, and operation also will change based on the daily feed. So there will be 3 major products from the pyrolysis process. First is the gas, that majorly will be the hydrogen, methane, carbon monoxide, carbon dioxide, and that will be 20 to 50% of weight of the input. And liquid, that is tar, oil, water, that major composition is a tar. So here in the gas, the major composition is hydrogen, and liquid, the major composition is a tar, and for solid is the major composition is a char. But I think we can't say exactly. Normally this gas also, normally we called as a syngas. So a synthetic gas and a highly combustible gas will be able to produce that. This liquid also can be used as in tar, and solid also can be used for as in the form of char, but need some kind of treatment for that. So, here by this you can see that there will be 3 major products. Now, the gasification. So, gasification is also a thermal and chemical conversion. So, here temperature is 800 to 1500 degree centigrade and is a partial oxidation. Okay. Partial oxidation with a gasification agent, typically air, steam or oxygen. So, is a partial oxidation. Now what will the difference between incineration and gasification? So, incineration is a 100% oxidation, complete oxidation is a complete oxidation or complete combustion of organic matter. And what are the products also? The same way like in the pyrolysis process, the gas, liquid and solid. So, obviously we are calling is a gasification process. So, gas concentration is more, like the quality will be the similar, but the quantity is more 20 to 60%, and liquid, that is also tar and oil, but I think the quality is somewhat good than the pyrolysis process, and solid also the ashes 20 to 30% of their weight of the plant. So, this is a small scale gasifier, that is biochar based gasifier. Now, gasification of MSW is accomplished in the 2 chamber. So, here you will see that there are 2 chambers, one is primary chamber and second is a secondary chamber. So, in the primary chambers operated below the stoichiometric air requirement, waste is semi pyrolysis, release moisture and volatile components. Heat is provided by the controlled combustion of fixed carbon within the waste. So, here is the primary one, primary chamber. So, the idea of this primary chamber to release the moisture, that was the major one, where temperature also will be low, and secondary chamber operated under excess air condition. Here the small amount of air is getting put it for in the primary chamber for the combustion process. A syngas that is driven off contain a high calorific value and can act as an feedstock. Okay. So, is again depend upon the design. So, normally the gasifications will have 2 chambers, primary chamber followed by secondary chamber. Now, type of reactors, the gasifier, that is a counter current, co-current and fluidized bed and rotary kiln reactor. There are different technology itself in the gasifications. So, and that is depend upon the how we are putting the air inside the reactor. So, the first is the counter current, you see here, this is the second co-currents, fluidized bed where waste will be in the fluidized condition, and finally is a rotary kiln. Okay. So, we will go one by one. So, first is the counter current gasification. So, there also fixed bed reactor, the bed is fixed here, this is the waste, that is this is the particular bed, and gasification agent flow into the counter current manner. So, it will go like this. Cylinder shaped reactor mounted vertically and waste is fed from the top of the reactor and solid output collected from the bottom. So, the waste is fed from the top and the ash will come out. The gasification agent is supplied from the bottom and then the off gases are collected at the top. So, this is the gasification agent and gases will come out from the top. So, what are the advantages of that? Simple construction and high thermal efficiency, since upward flow of gases through the reactor also heat the waste. So, obviously the air is supplied upward. So, obviously the proper combustion could be possible here. Now, the disadvantage, the high tar production, potentially carryover of dust with the gas, slagging and difficulties with control temperature zone within the reactor. So, these are few disadvantage of the counter current gasification. Now, the co-current gasification, you see here air is directly entering into the waste material. Design is similar. The gasification is introduced at the upper part of the bed and gasification agent and waste flow concurrently towards the bottom of the gasifier. So, what are the advantages of that? Increased breakdown of the tar as the gasification agent passes through the hot char in the high temperature oxidation zone before leaving the gasifier. Low requirement for the gas cleaning. Okay. And disadvantage is prone to clogging due to reactor geometry, which make them difficult to scale up. So, because air gasification agent is directly entering into the waste material, so clogging could be the one problem here. Now, next is the fluidized bed gasification. Now, here see entire waste is in the fluidized condition. The solids are in the motion, but retained within the reactor. Heat conducing bed material used to transfer heat to the waste. So, what are the advantages? The better mixing and heat transfer resulting in more uniform bed condition and improved overall conversion efficiency. It can be scaled up. Okay. And disadvantage, scale up studies should be conducted. I think that is also one of the important point. See, in India, especially in the academic institutes, I think research onto the combustion is very difficult. Maybe I think small unit we can design, we can fabricate small unit, but scale up is again difficult task. And especially these both the methods like pyrolysis, gasification, we do not have much literature in India. The small one, small scale facilities are available. I think especially the chemical engineers, they used to work into pyrolysis and gasification, but I think scale up studies are not available with us many. And this is the rotary kiln gasification, slowly rotating and highly inclined cylinders are used. The waste slowly move down to the cylinder and the gasification agent is introduced at the bottom end of the gasifier. So, the waste retention time is longer than in the case of fluidized bed gasifier, but shorter than in the counter current and co-current gasifier. Okay. So, these are the few gasifiers. I think in India we won't find the pyrolysis and gasifiers for the MSW, municipal solid waste, because their major problem in India, you know that segregation is the major problem, and for that the feed should be highly segregated material. Not only segregated, but also required very high calorific value waste. But I think I personally believe that these both methods are highly beneficial. If you compare with the incineration process, simple incineration process, grade based incineration process, see there always we have to talk about emission quality, fly ash, solid residue and huge production of these pollutants are producing. But here in the both the treatment facilities we never talked about the pollutants. Whatever the gas is producing, that we are calling as in syngas, highly combustible gas can be easily get utilized. The solid, liquid is a tar, oil, that is also a very high calorific value. Solid char, that can be used, highly combustible material easily can be used for the road as in road construction purposes after very primary treatment, or otherwise also we can use it for many other places. So, I am also willing to see the pyrolysis or gasification plants for the MSW, but I think we do not have much research onto that. Especially to inform you, IIT Guwahati also I started one projects. I think we are especially looking onto the these integrated pyrolysis and gasification plants. So, here the thought is that simple waste, first it will go for pyrolysis, that will produce gas, liquid and solid. Again these three products are getting gasified and that these whatever the products will again come up, this will be highly beneficial products can possible to come up. The thought is that the way waste is getting feeded, it will start from the 50 degree small temperature, it will goes up to 800 degree centigrade temperature. Okay. And now this is the pyrolysis process, where drying, it will start from the drying and after combustion. Finally, this entire one, it will add into the gasifier, where temperature can go up to 1600 to 2000 degree centigrade, and again that entire products will get combusted. I think we required, I think, research onto that, the especially scale up units or small units and followed by the scale up units. So, let us see. So, what are the benefits of pyrolysis and gasification with respect to the incineration process? Okay. That the first benefit is that the possibilities and flexibility to recover chemical energy in the waste as an hydrogen. Okay. That is the major production in the gas. So, otherwise in the incineration hot flue gas is producing, that is why we called as a syngas, and here we are calling as a flue gas in the incineration. Potentially better overall energy efficiency if you compare with the incineration facilities. Less trouble with corrosion. I think that highly corrosive gases are producing into the incineration process, and always has to check your all the equipments there, but here there will not be a much corrosion. Corrosion because there are a lot of metals are also getting, volatile metals also are getting generated into flue gas, because of that the corrosion is a major problem. Less need of flue gas cleaning, and in gasification and pyrolysis process, because the small volume of flue gas with a better quality. Potentially better option for CO2 capture also, potentially lower emission of dioxin. This is also one of the important one. So, when you talk about incineration and whenever we talked about flue gas production, I think dust, acids, metals, nitrogen, the oxides of nitrogen, that is possible to remove. Again we have to treat for the dioxins and furans also. So, here there is a lower emission of dioxin and improved quality of waste solid residues, particularly for high temperature process. The gasification unit operating with a low fuel load potentially facilitates small plants producing less than 1 megawatt plant. Small units could be possible and potentially lower cost. I think there the capital cost is very high, and also followed by maintenance cost is very high in the incineration process compared to the gasification and pyrolysis process. So, main drawback of current technology for pyrolysis and gasification, few drawbacks also I am sharing that. I think I do not know whether is a drawback or is a requirement for pyrolysis gasification process, that highly homogeneous fuel are needed, and that is the major problem with the MSW. I think it's very difficult to get the homogeneous phase, but see that in the corporation area also lot of agriculture waste is getting generated, and this agriculture waste is highly homogeneous nature. Even the small scale industries also, the waste is highly homogeneous nature, because particular industries also is producing particular kind of waste. If it is organic in nature, obviously we can have the pyrolysis and gasification process, but for MSW is a major drawback. The slagging, tar production and contaminants in the produced gas are common. So, I think slide I shared that gas is separate and solids is separate, but I think there also in synthetic gas the tar or solid could be possible there. Existing technology only demonstrated in small scale and not applicable to specific fuel types. Overall energy conversion efficiency of existing installation have been unable to compete with the modern waste incinerators. So, that is also one of the drawback, because I shared that we need lot of literature for that, so that we can compete with the other incineration technologies. Now, the process parameter to run the pyrolysis gasification process, I think what are the range of parameter may influence the pyrolysis and gasification process, where reactor design, waste composition, waste pre-treatment, process temperature, heating, residence time and pressure, what pressure we are combusting the material. So, there are lot of parameters are influencing the both the processes. So, because of that also I think I can say this is one of the drawback, where lot of parameter has to be studied first before running the pyrolysis and gasification process. So, the technology wise, long range of pyrolysis gasification technology exists. From a waste point of view, two main aspects differentiate the technology. One is energy recovery technology, focus on generating the syngas suitable to utilization in a gas motor, gas turbine to produce electricity. And second is material recovery, focus on producing the stable solid residue. So, the first aspect is syngas production and second is stable solid residue production. Could be used for the construction work or for other purposes. Material recovery often occurs on the expense of energy recovery, obviously. So, now categories of reactor is a one stage process, either pyrolysis or gasification process, typically used on more homogeneous feedstock, and two stage process, which I shared about two stage. Okay. So, used for complicated feedstock such as mixed municipal waste, that is what I was sharing that. If you are able to do the two stage process, means pyrolysis followed by gasification, could be possible to utilize the mixed MSW. So, pyrolysis process typically take place in the first reactor, while the gasification process in the second reactor. Okay. That is a two stage process. So, okay. So, challenges of utilizing pyrolysis and gasification in the Indian context. I think there are few points I had been noted out, because what are the challenges before thinking or before trying to get installation of pyrolysis and gasification plants in India. First, the high calorific value waste, which may otherwise be processed in more sustainable process, is required as feedstock. So, need to be understand first, we need high calorific value waste, then only is possible to run the pyrolysis and gasification process. Organics can be converted into compost in a much more cost effective and environmentally safe against using them for this process. So, here the organics, any organics can be utilized for pyrolysis and gasification process. So, your wet waste also could be possible to utilize. Could possible that in many countries are running these pyrolysis gasification plant for sewage sludge, that is a dry or having 30 to 40% moisture also could be possible to get utilized. But I think already biological treatment facility like composting, anodization is already cost effective processes. So, why to use such kind of process into that, and requires specific feedstock quality, which has a direct impact onto the efficiency and commercial viability of the product. Very specific feedstock quality is required. Pre-treatment of waste is a must. Okay, means the cost is there if you say the pre-treatment, and specific size and consistency of solid waste should be achieved before MSW can be used as in feed. This is another very important point. Specific size, I think for that means you need very special kind of pre-treatment. So, pre-treatment means one special shredder is required, and after shedding a particular size of waste will come up for the pyrolysis and gasification process. But still I believe that this all whatever the challenges normally we will find in India or developing countries could be possible to solve, but for that we need research, in the especially in the academic institutes can come up with the scaled up pyrolysis and gasification plants. So, I have a few case studies for that. So, maybe 1 or 2 case studies also I personally like, and because very old one treatment plant is available, that is Ganganagar, Rajasthan, that is a gasification based waste to energy plant. So, is a Kalptaru Power Transmission Limited set up a biomass plant. So, is a biomass based agriculture biomass based plant, okay, in Ganganagar district of Rajasthan, year 2003, very old plant and still is running properly. The plant uses agriculture waste and crop residue as input and generate 7.8 megawatt of power. Okay. So, which I was sharing that, I think still we do not have for the MSW, but for agriculture residue is highly beneficial because of homogeneous nature and high organic nature of the waste. So, project also achieved gold standard certification year 2012, and gold standard is the only premium quality standard for the carbon emission reducing projects with added sustainable development benefits and guaranteed environmental integrity. I think for my knowledge that this is the only plant which will have the gold standard certification. Okay. So, because that is specially for the special kind of products where carbon emission is very less and guaranteed to have environmental integrity. There is another plant, is a Pune based waste to energy plant, gasification based. So, Pune Municipal Corporation takes care of 50% of city's waste in alliance with the Concord Blue Technology Private Limited. This is also under PPP mode maybe, and 25-year contract set up to implement the patented gasification reformer tower. The idea was to 10 megawatt energy to process 650 tons per day waste. The tipping fee for the tech solution provided around 300 rupees per ton. So, tipping fee, I think I have another module. I think that will be your last module of financing and PPP. There I will talk about this tipping fee. Now, here just one point I want to share just for this lecture. The tipping fee is that any private company is collecting the waste and whatever treatment they are doing and whatever amount they are collecting, the local authority will give payment against that. So, that is called as a tipping fee. So, for 1 ton of waste is a rupees 300 rupees per day. So, remember that for 650 tons per day there is a huge amount of money has to be paid to the private authority. The cost of the plant was 14 to 15 crores per megawatt, with the generated cost of electricity coming to rupees 13 per kilowatt hour. So, this is offset by actual price paid by the electricity board, the tipping fee involved and other incentives. So, features of the well implemented waste to energy plant. What are the, I think this is our last slide. So, what are the features should for well implemented waste to energy plants? The reduced volume of the waste with minimal or no waste sent to the landfill. That should be the thought, and generate energy through gas, power and fertilizer, ensuring waste is utilized thoroughly. Usable solution in small town along with the large urban centers, decentralized processing with minimal transportation, absolutely no hassle. So, emission should be aligned with the defined environmental norm, economical implementation, finally financial viable. So, here we will finish this module entire. We had a 5 lectures and I believe that you people have completely understand the incineration, proper waste to energy plant, incineration, but finally what point I want to mention that earlier also I was also against the incineration facility, because the same waste which is combustible also are recyclable, like paper, plastic, rubber, leather, even organics are recyclable, could be recyclable or could be compostable or biologically degradable. But I was thinking that having such kind of facilities also in India, there are most of the cities have composting facility, recycling facility, but still we are not able to handle the waste, because it's a mixed kind of waste and everywhere the segregation is not possible. So I think, I believe that we need to have the incineration facility in India, and both kind of like incineration plants and also the pyrolysis gasification based units for different kind of waste. And I believe that next 15-20 years we will have more such kind of incineration plants or combustion facility or waste to energy facility. And only the point has to be mentioned that we need to really work onto the treatment facilities. If we are able to treat the flue gas emissions or flue gas polluted gas, I think we can run the incineration facility. So from next module, I think we will go for biological transformation. We will start with the composting. Okay, thank you.